Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at geometry and measurement, and specifically we'll be working on shapes in space. Here are the lesson objectives. And without much ado, let's quickly look into them. Now, since this particular session is just on solving questions, if you want in-depth tutorials on all of these, you can always check on the playlist where you'll have what in-depth tutorials on all of these. Without much ado now, let's solve the question. As usual, I will advise that you get your notepad and your pens or pencils with you so that you try to solve before checking for the answers. Question number 1. Question number 1 says, what is the name of an angle that measures exactly 90 degrees? An angle that measures exactly 90 degrees is a right angle. Starting from an acute angle is an angle that measures less than 90. Then go to a right angle. A right angle is exactly 90. Then go to obtuse, which is between 90 and then 180. Then on a straight line, that is 180. Then more than a straight line is what? A reflect angle. So our answer is what? A right angle. Question number 2. An angle measuring 45 is classified as, that is an acute angle, just as I have explained. Question number 3. If an angle measures 210, it is known as what? It is known as what? Yes. So that is a reflect angle. Two angles are complementary if their sum is. What are complementary angles? So when we talk of complementary angles, then we have two angles whose sum gives us what? 90 degrees. So for what we have here, if I'm to draw another arm of an angle here, any of these two we say are what? Complementary. Because if we add them together, we are going to get 90 degrees. So that is what? 90. Question number 5. What is the complement of 30? What is the complement of 30? This question here is asking that if you have one angle and then we say its measure is 30 degrees, the complement means the other adds to it to give you what? 90. So what then is the value that we need here so that we get what? 90 degrees. So you can easily solve by saying what? X plus 30 should give you what? 90 degrees. Then we have x being equal to a 90 minus what? 30. And that gives us a 60 degrees. As simple as that. Question number 6. Two angles are supplementary if they add up to what? So for supplementary angles, they are also called the straight line angles. That is, they sum up to 180 degrees. And for this case, we have to find the supplement of 115. So let's say you have an angle which is 115. If all of this is 115, well, not drawn to what scale, then what angle should this be so that it becomes what? 115. So we say 115 plus x should give us what? 180. Then we make x the subject. So we have 180 minus 100 and what? 15. Subtracting, we'll get what? X being equal to a 65. So that is A. Now question number 8. When two lines intersect, an angle opposite each other at the vertex is called what? So when we have two lines as these, we get 4 pair of angles that are formed. You can get angle A, angle B, angle what? C, and then another angle over here. Now, all these angles, that is this and this, can be said to be equal, and we call them vertically opposite. They are opposite to each other. So they are vertically opposite angles. Question number 9. If angle A and B are vertically opposite and angle A is what? 72. What is the angle B? Earlier on I said vertically opposite are equal. If we are being told they are vertically opposite, then we should assume they are what? Equal. So if A is 72, then B is also what? 72. As simple as that. Question number 10. The sum of angles on a straight line is always the sum of angles on a straight line. So on a straight line, we have what? 180. These are very, very simple and then direct questions. What is the sum of angles at a point? And it says into bracket a full circle. So at a point, if you go round in circle form, we say you have done a 360 degrees. So as you can see here, if we move in circles, then we have gone around 360 degrees, and that is C. If three angles at a point are 100, 120, and X, you have to find the value of X. Take note, these are angles at a point. So for angles at a point, we know their sum gives us what? 360. So our angles are 100 degrees, 120 degrees, and then X. So since they are at a point, we can say that 100 degrees plus 120 degrees plus our X is equal to 360. And what property is that? That is angles at a point. Making X the subject, we have 100 plus 120, which gives us a 220 plus X. And that should give us 360 degrees. So our X is simply 360 minus 220. This, when subtracted, gives us a 140 degrees. And that is the value of our X. As simple as that. 13 says, which tool is primarily used to measure the size of an angle in degrees? That is a protractor. We use protractor to measure sides of angles. Question number 14. In the construction of 60-degree angle, where do you place the compass point to draw the first arc from the line? So if you want to construct a 60-degree angle, it says, where do we place the compass point to draw the first arc from the line? So most of the times, as you can see here, with my compass, I'm coming to bring it to the end of the line. You see, at the vertex of the line. And with that, I'm going to draw my arc. You see, so it is with this arc that I can now move and then draw my other arc that would indicate what? My 60 degrees, right? So the first step we had to take was to stand at the vertex and then draw our arc. You see, so at the vertex or the starting point of the line. Question number 15 says, to bisect an angle means, to bisect an angle simply means you are dividing the angle into two equal parts. So for what we have on the screen here, if I'm actually bisecting this 60 degree, I would stand here and then I'll draw my arc somewhere around here. And then I'm going to stand here as well and then draw another arc somewhere around here. Then with that, all I do is I pick my ruler and draw a straight line from the point of intersection through this. And with that, you realize that the angle formed here would be the same as the angle formed here. And in this case, since it is 60, then they are both going to be what? 30, 30 each. So to bisect an angle means to divide the angle into two equal parts. Question number 16. If you bisect 90-degree angle, what is the size of each resulting angle? Earlier on, we said to bisect an angle simply means we are dividing the angle into two equal parts. So in this case, if we have 90 and we want to divide it into two equal parts, what are we going to get? We are going to get a 45, right? So each is going to be what? A 45 degree. Number 17. What is the result of bisecting a 30-degree angle? 30-degree angle. Bisecting, once again, means to divide into two. So if you have 30 and you want to bisect it into two, then each is going to be what? 15 degrees. As simple as that. Number 18. When constructing a perpendicular bisector of a line segment, the compass width should be what? So I'm coming to draw a line segment here that will be constructing a perpendicular bisector with it. Now, if you want a perpendicular bisector of this particular line, then you at least need to pin at the beginning and make sure your opening, the width of this compass, becomes a little bit bigger than half the length of the line, so that you can get an arc above and then below. And with this same opening, we move to the other end of the line and draw another arc above and then below. After which, we then draw a straight line through these points of intersections. You see? And that becomes our perpendicular bisector. Very, very simple. So in short, what do we need to do? We need to open the width more than half the length of the line. So looking at question 19, it says to construct an angle of what? 75. Which two standard angles are usually constructed first? Now there are basic standard angles that we construct. That is, some of these basic angles are 90. So we have the 90, the 60, and then even the 30. You see, now it is with these angles that we can bisect and then get others. So for instance, if you have to construct angle 90 degrees, which we do see on our screen. So for 90, all you need to do is to draw your semicircle. Then with this semicircle, you can then stand right here and then draw an arc. So I'll be standing here to draw an arc, one upward and then the other from this other end. So with a 90, I can also construct a 60 degrees. So with a 60 initially, we shouldn't have even closed our compass. So you stand here and then bisect from here. You see. So what we do is we take note of our 90 and then our 60. You see. So this angle formed over here, that is in between here. You see, if you are to bisect it, it is actually, so this being 90 and then this being 60. In between here is a 30-degree angle. So if you are to bisect it, we would get 2 of the 15 degrees. And if we add that 15 to the 60, that gives us a 75. So to construct 75, you have, or you need to construct these two basic angles, that is the 60 and then 90. So looking at question 20 as well, it says an angle 105 can be found by bisecting the region between which two parts. Now take note, these same angles we have over here, that is the 90 and then the 60. Depending on the calibration of our compass, they can also be what, 90 and then a 120. You see, so if that is the case, and we want to use, for my case, if you want to use the inner calibration, then this 60 here is actually 120. And as you can see, if you are to bisect in between this, you are going to get a 105, as you see over here. So with the same set of principle we use, this one is what, 120. And if we bisect it, we get what, a 105, right? So question number 22. What is the name for a pair of angles that lie on the same side of a transversal and between two parallel lines? What is a transversal? Let's first of all look at what parallel lines are. So if this is a straight line, and then I add one more to it, these two lines become parallel lines. Why? Because they do not meet even if extended. And if I draw another line that touches these two lines, we call it a transversal. For the transversal, so many other lines are formed. The one we are focusing here is the ones we have in here. So we have these two. We call these two angles co-interior angles because they are inside. They are inside this C shape that is formed over here. So that is what number 22 is. B, co-interior angles. Now, if two parallel lines are cut by a transversal, then we say the alternating angles are always equal. When we say alternating angles over here, then we simply mean if I take this angle and then I also take this angle, you realize that if I'm to turn it around, there are some that will easily fit into the other. So for instance, for this we have, if I'm to turn this all the way, so if I'm to turn, you realize that this, which is now here, comes to take place of this. You see, we call these angles alternating angles, and they are always equal. All right. Question number 23. In the Z-shaped pattern formed by the transversal crossing parallel lines, the angles in the corners of the Z, what do we say they are? So it is just as we just did. So these are the corners of the Z. See, they are the alternating angles. You see, because if we turn them around, they take the place of the other. Corresponding angles are equal. Which letter shape helps identify them? What do we mean by corresponding angles? So first of all, if you look at what we have over here, there are so many shapes that can be formed. We have the Z. We have considered the Z, and then we said that helps us to get what? The alternating angles. Now there are also C shapes over here. This C shape we have also considered, and that helps us to get the co-interior angle. There is another one here which looks like an F, and for the F, it helps us to get what? The corresponding angles. So the corresponding angles are these. This angle here, and then this. You see, they correspond to each other. And we say the corresponding angles are always equal. The same applies to this you have here. So this angle also corresponds to this. You see, corresponding angles are always equal. So it is the F shape that helps us to do what? Identify the corresponding angles. There is a property we have on co-interior angles. We always say that co-interior angles between parallel lines are what? Supplementary. You see, so if this is A and then this is B, and if they are co-interior, then we say if we are to sum them up, we'll get 180. This is one property of co-interior angles that we need to know. This is question number 25, and then our advice, you take rest for now, just for about 1 to 2 minutes till I come, and then we proceed. Okay, so welcome back. Let's look at question number 26. If an angle is 130 degrees, its adjacent angle on a straight line. So we have two terms we need to take note of over here. First of all, we are talking of adjacent angles and then on a straight line as well. Adjacent angles are simply angles that share a common arm. And then a straight line is just an angle whose sum equals 180, or they are supplementary. So in this case, we are saying these two angles share a common arm. And then one is 130 and it is adjacent to the other. Now 130 plus what gives us 180. So 130 plus x equals 180. To solve for x, we have 180 minus 130, which gives us a 50. So the value of the adjacent angle is what? 50. Question number 27. What is the angle between north and east direction on a compass? So for this, we need our cardinals. So for our cardinals, we have this representing the north and then the south, and then this also representing the east and the west. So we have our north here, our south, the east, and then the west. This is what is the angle between the north and then the east. That is always a 90 degrees. So that is A. Question number 28. Find the value of x if x and 2x are complementary. Earlier on, we said complementary angles sum up to what? 90 degrees. So it simply means this angle x, when added to 2x, should sum up to 90 degrees. You see, so making x the subject, we have 3x being equal to a 90. We have to divide both sides by what? 3. So divided by 3, divided by 3. This cancels out this, and we have our x being equal to what? A 30. So the value of x is a 30 degrees. Question 29. It says, find y if y and 4y are supplementary. Supplementary angles sum up to what? 180. If we have y and 4y and we are saying they are supplementary, it simply means when we add them, we are supposed to get a 180 degrees. So 4y plus y gives us a 5y. So we have our 5y, which when divided by 5, dividing both sides by 5, we have 5 cancelling 5. Then we have our y being equal to what? 36 degrees. We have our question number 30. If two angles are vertically opposite and also complementary, what is the size of each? So we have two angles here which are vertically opposite. Vertically opposite comes as a result of we having what? The X shape. So if I have angle A and then I have angle B, and we are saying they are vertically opposite, fine. Vertically opposite are equal. So it simply means A is equal to B. And we are also saying that these two angles are complementary. So it means A is equal to, so it simply means A plus B is equal to what? 90. And since they are all the same, then we can simply say A plus A equals 90. Simplifying further, we have 2A being equal to 90. We are then going to divide both sides by 2. So that we have 2 cancelling out 2, then we have our A being equal to 45 degrees. And that is D. Question number 31. It says in a triangle, the sum of interior angle is what? It is always 180. Okay. For a triangle, irrespective of the type of triangle it is, whether isosceles, equilateral, right angle, scalene, or what have you, acute angle, triangle, reflect angle, triangle, obtuse angle, triangle, they all have their interior angle summing up to 180. Question number 32. If a triangle has angles 50, 60, and then what is the third angle? Now let's let the third angle be what? Any variable at all. So let's just let it be T. If the others are 50 degrees and then 60 degrees, then it simply implies that if we are to add all of them, 50 degrees to 60 degrees and then to T, we're supposed to get a 180 degrees. 50 plus 60 gives us a 110 plus our T should give us 180 degrees. So our T is equal to 180 degrees minus 110 degrees. So subtracting, we have what? 70 degrees. And that is our C. Question number 33. An isosceles triangle has one angle of 100 degrees. What are the other two angles? First of all, what is an isosceles triangle? An isosceles triangle is an angle which has two sides equal. You see, and if two sides are equal, then it simply means two of its angles are equal. We mostly say it has two of its base angles being equal. So with what we have here, it is always the one at the top that becomes different. Hence, this angle is equal to this angle because they are what? It is an isosceles triangle. In that case, we know the sum of interior angles of a triangle equals what? 180. So summing all these, we have x plus 100 being what? 180. So making our x the subject, we have 2x equals 180 minus 100 degrees. So we have 2x being equal to, if we subtract this, we have an 80. Then we divide both sides by 2. So our x is equal to 40 degrees. So that is A. Question number 34. 34 says, what is the size of each interior angles in an equilateral triangle? So for an equilateral triangle, we know all the sides are the same. So though this is not drawn to scale, let's assume it is an equilateral triangle. So if it is an equilateral triangle, then the angle we have here is the same as this angle, and it's also the same as this. Right? So if this is an x, this is an x, and then this is also an x, then we say x plus x plus x should be equal to what? 180 degrees. We have 3x being equal to 180. So if you want our x, all we need to do is to divide both sides by 3. So that we have x being equal to 60 degrees. There is a property that is constant. Hence, you don't always need to solve to determine. Take note that the interior angles of an equilateral triangle are always 60 degrees. And with that, you wouldn't have to even solve. Question number 35. It says, a right-angled isosceles triangle has which of the following angle set? We said an isosceles triangle is that which has what? Two of its sides equal. This one in particular is a right-angled triangle. It is also an isosceles triangle. What this means is the two arms meet at 90 degrees, all right. And then we have this other, which you call the hypotenuse. Now this is the same as this. Their lengths are the same. And this angle is at 90 degrees. So if this is a 90 degrees, then the angle here is the same as the angle here. If they are the same, we also know that if we are to add them all together with our 90, we have to get 180 degrees. So we have a 90, then plus this x plus this is giving us 2x, which gives us a 180. So our 2x, when made the subject, 90 moves to the other side, and then we get what? A 90 degrees. So solving for our x, we get our x, which is equal to a 45 degrees. So it means this is a 45 degrees. This is also a 45 degrees, and we have our 90 right here. So it is a 90, 45, 45. That is B. Then let's look at 36. Which of these is the correct first step to bisect a given angle A, B, C? If you want to bisect an angle, the first thing we do is to draw an arc. You see, so if you have an angle and you need to bisect it, you need to first draw an arc. So let's take this for instance. If I want to bisect this angle, then I need to draw an arc. First of all, by standing at the vertex of the angle, that is right here, then I'll draw an arc. So it is with these two arcs that I can then stand at what? This point, first of all, draw one arc, and then I'll stand at this other point and also draw another arc. After which, we can then draw a straight line from the vertex of the angle through the points of intersection. So we draw an arc with center B to cut what? AB and then BC. Question number 37. In geometric construction, why is the hard pencil like H2 preferred over soft one like 2B? The main reason is we want to produce more accurate drawings. Look at the pencil I used to do this construction on the screen. Now I'm going to change the thickness, and then we'll see what is going to happen. As I've changed this thickness, you realize that at least what we've done, you can really see it clearly and then take note of your intersections. But then if I'm to use a deeper line, such as this becomes less accurate, because if you are to measure an angle, if I put my protractor in here, you wouldn't know what line I am drawing. And even the line through our protractor even traces more than one point, as you can see over here. You see, the width of the line itself is very thick. Hence, it produces what? Thinner and more accurate lines. That is the reason why 2H or the other grades of H are preferred than the other grades of B. Question number 38. To construct a 90-degree angle at a point on a line, you effectively construct. What are we actually constructing? So to construct a 90-degree angle at a point on a line, you effectively construct, I think for this, since it is 90-degree you want to construct, you end up constructing two things. The first one is you construct a perpendicular to the line at that point. When we say perpendicular, two lines are said, a line is said to be a perpendicular of the other if it meets the other at 90 degrees. Okay, so this is simply how we construct 90 degrees. So I have my semicircle, and then I stand at one point, open my compass, and then I'll draw my arc here, and then I also draw another arc over here. Now take note, you now draw a line to meet where you have the center of your circle. So most of the times you take note of it before you even continue. So I'll draw a straight line through this. Now this line here actually meets the other at an angle of 90 degrees. You see? And then secondly, we have also constructed an angle bisector of 180. So we know all this, which is a straight line, measures an angle of what? 180. If you have constructed a bisector to it, where we have 290 degrees, then it simply means we have bisected the angle 180. So the answer can be A or B, as you can see over here. Question number 39. So our next question here says, if you are given the angle 150 and you bisect it, then you bisect the result again, what do you get? Bisecting 150 alone simply means 150 divided by 2. When we divide 150 by 2, we are going to get a 75. Now for 75 divided by 2 as well, then we are also going to get a 37.5. And that is what? C. So our question number 40. An angle A and 142 are angles on a straight line. What is A? Take note, we've been told there are angles on a straight line. Sometimes all you need are these petty clues to tell you what to do. So since there are angles on a straight line are simply supplementary. Hence, if we add 142 degrees to A, you're supposed to get a 180 degrees. So our A is then 180 degrees minus 42 degrees. Then what do? We do a subtraction. So our A is just a 38 degrees. That is 180 minus 142. So let's look at 41. Question number 41. It says we have two lines. We have L1 and then L2. So this becomes our L1 and another here being our L2. And they are parallel. Now a transversal cuts them. If one co-interior angle is x, and then the other is x plus 20. So you are going to let this be our x, and then the other becomes x plus what? 20. Now to find the value of x. So for these two, we said that co-interior angles sum up to 180. So if the first one is x, plus the next one, which is x plus 20. It sums up to what? 180. So x plus x gives us a 2x. And we have our plus 20, which then gives us what? A 180. Making our 2x the substitute, you have 2x being equal to 180 minus a 20. So 2x equals 180 minus 20 gives us a 160. If you have to divide both sides by 2, we are going to get our x being equal to an 80 degrees. And that is what? The D. Very simple. Question number 42. It says, in a diagram with two parallel lines, if a corresponding angle, so let's try and then illustrate that here as well. So it says, if a corresponding angle is 45 degrees, what is the value of its vertically opposite angles? The corresponding angle, we can have it here as 40, that is as 65 degree. And if it is corresponding, then we are talking of this as well being what? 65 degrees. The angle that is vertically opposite to this will be what we have over here. You see, and we know that vertically opposite angles are equal. So if this is 65, it vertically opposite is going to be here, and then it's also going to be 65. So vertically opposite angles are equal. Hence, we have what? 65 degrees. Question number 43. What is the sum of the exterior angles of any convex polygon? Now, don't let this convex here confuse you. For any polygon you have at all, the sum of the exterior angle is what? 360. Whether it being a triangle, a square, or the quadrilaterals, pentagon, nonagon, decagon, or dodecagon, all of them, the sum of their exterior angles equals 360. Take note of that. Question number 44. So for question number 44, 44 says, if an exterior angle of a regular polygon is 40 degrees, how many sides does it have? So for one exterior angle, we know the formula is given as 360. 360 being the total exterior angle over n equals what? 40 degrees. And it's all about making your n the subject. So cross multiplying, we have 360 times 1, which remains 360. Then we have our 40 times n. Since it is n all we want to do is to divide both sides by 40. So divide 360 as well by what? 40. So with that, 40 takes out 40. Then we have 40 into 360. How many times? That is 9 times. So it simply means that n is equal to what? 9. So it simply means a polygon with a 9 side is that which has an exterior angle being equal to 40 degrees. Question number 45. In a quadrilateral, the 4 interior angles add up to. So for quadrilateral, it is always 360. But if you do want to solve, we know the sum of the interior angles is given as what? N into bracket. It's given as 180 into bracket n minus 2, where this n represents the number of sides of the polygon. The quadrilateral has 4 sides. So you have 180 into bracket 4 minus 2, which then becomes a 180 times 2. 180 times 2 gives us a 360 degrees. And that is our B over here. Question number 46. It says a reflect angle is 240. What is the size of the interior acute obtuse angle at the same what vertex? So what does this mean? What they mean here is if you have to draw something like this, you see, this whole angle here is 240 degrees. So 240. In this case, that becomes the exterior, but then this here becomes the interior one. So what do we need to add to it? You see, because they are having the same vertex, the sum of these two gives us what? 100. It gives us a 360 degrees. So we say a reflect angle and the interior angle must add to 360. The reflect angle and then the interior should add to what? 360. Hence we have 240 plus the angle we don't know, let's say A, giving us a 100 and giving us a 360 degrees. Making our A the subject, we have a 360 degrees minus 240 degrees. And if you have to subtract, we'll get a 120 degrees as the interior angle at the same vertex. Question number 47. 47 says, if you construct a 60-degree angle and then you bisect it. So first of all, if you construct 60 and we bisect it, we are going to get a 30 degrees. Now it says when we bisect it again, so we are going to bisect this again, and that is going to give us what? A 15. So if you construct 60 and bisect again, we'll be getting a 50-degree angle. Question number 48. It says, find the angle X in a triangle where the angles are. So we have, it says we should find the value of X. So we have X, 2X, and then 3X. Now take note, when it comes to a triangle, we know the sum of its interior angles always sums up to what? 180. So for this case here, it simply implies that our X plus our 2X plus the 3X should sum up to 180 degrees. X plus 2X plus 3X gives us a 6X. So we have 6X being equal to 180 degrees. And how do we get the value of the X? We divide both sides by 6. So that this 6 cancels out this 6. And we have our X being equal to what? A 30. So it means the value of the X is what? A 30 degrees. As simple as that. Question number 49 says, which of these is used to ensure a ruler is straight and a horizontal or vertical? Sorry, it says, which of these is used to ensure a ruler is straight and horizontal or vertical on a drawing board? You know what a divider is, those two pins. You know what the compass is. The protractor, on the other hand, used to measure an angle. And then we have the T-square. So it's the T-square that hooks onto the side of the board to maintain a perfectly horizontal line. Our last question, which is question number 50. Question number 50 says, a transversal crosses two parallel lines. So let's get our parallel lines and then our transversal. And so a transversal crosses two parallel lines. An alternate interior angle is 5y plus 10. And its partner is 2y plus 40. what they are talking about here is the z. So we know it is the z that forms the alternate angles. Hence, one of this is what? And 5y plus 10. And then the other is also a 3y plus 40. Now we know what happens to alternate angles. You see, alternating angles are always equal. So this simply means the angle we have here as 3y plus 40 is equal to the 5y plus 10. So let's make y the subject. We have 3y minus 5y being equal to our 10 and then minus 40. 3y minus 5y gives us a negative 2y. We are saying that is equal to a negative what? A negative 30. If we want our y, we would have to divide both sides by a negative 2. So this cancels out this, and it simply implies our y is equal to what? A 15. Hence, the value of y is 15. This is our last question. This is how Beyond Numbers, where we learn maths the easy way. There are tutorials to all these that we've done on the section of geometry. You can always switch to any of those videos for in-depth tutorials just to enhance your understanding. If there's any issue of concern, you can always let me know in the comment section, or you can message me on Telegram. That is on the homepage where I have my links. See you in our next lesson, and bye for now. Do stay safe.
That's right, you've reached the final frame. Let's celebrate this learning game. With every number, big or small, you learn to stand up straight and tall. The easy way, you found the key to solve the puzzle wild and free. So don't you ever be afraid of all the progress that you've made. Beyond Numbers, yeah.